Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video we're going to be treating how to measure the formwork for the construction of a staircase. Now formwork can be measured in two ways. It can be measured in linear meter or it can be measured in meter square. It's measured in linear meter in the case of the riser and the formwork for the waist. However, formwork can be measured in square meter when you are talking about the soffit of the soffit of whatever you want to cover. So in this case, the soffit of the staircase now will be measured in meter square. The formwork for the risers will be measured in meter. The formwork for the waist will be measured in meter. So the first thing we're going to be measuring for would be the formwork for the waist. So if you look at this this diagram, that's this section, you know that we've calculated for the length of our string. So now we're going to be needing a length of wood or foam that would cover this string or this waist like this. So we can now use the length of our string that we've calculated as that length, because if we have a wood that can cover this whole place like this, it will prevent concrete from pouring outside. So what we can now say is 3.39, which is the length of the string that we've calculated for, which is this x. We calculated it as 3,385, which is 3.39 in meters. So 3.39 would be the calculation. So since 3.39 is the length of our string in one flight, that means we're going to be needing as much as this length of formwork for the two flights, because they are the same length. So you multiply it by 2. So when you multiply this by 2, you are going to be having 6.78. So you describe plain formwork to the sides of stair waists. And then you close. So after doing this, you measure for the formwork for the sides of the stair waists. Next you are going to be measuring for would be for the risers. So if you look at this drawing, for example, there will be formwork like this. To give support to the concrete pouring into this part. So it means that here like this would be covered. That's the formwork for the waist that we just measured for. It will be covered like this. Here like this will be covered. Now inside there will be another form for the risers. So now that is measured in linear meter. So in order to calculate for that riser, all you need to do now is to get the width of your staircase, which in this case is 1,200. So those forms for the riser will be as long as the width of the staircase, which is 1,200. So you book 1.20 for 1, but we have 9 steps, meaning that we are going to be having 9 risers. So you multiply it by 9. So if there are 9 risers in one flight and we have 2 flights of 9 risers, we multiply it by 2. and doing that we are going to be having what 21.60. so we describe ditto because it's the same operation, plain formwork, staircase risers, and then you close. Doing that, you measure for the formwork for the risers. The next one we are going to be measuring for now would be for the sides and for the soffit of the landing. Now, if you look at this drawing, I said that the landing is going to protrude into this wall, so we're going to be needing a form to cover this part outside so that the concrete will not be pouring outside. Secondly, we're going to be needing foam that will be covering this middle part here, which in this case is giving us what 100. So once we cover this side, and then we cover this part of the landing that is going to be showing, that means we've covered for all the sides of the landing. So we're going to be covering for the external side, this little side, and this part of the landing that will be exposed. So we are going to be starting with this part. So we know that the volume of the length that we calculated here is what 2.6. Initially it was 2.5 meters, but we added extra because it's protruded into the wall. We added extra 50 on both sides. That will give us what 2.6. So now from that 2.6 we need a formwork that is going to exceed that 2.6 so that it can be nailed to the wall. It cannot be nailed on just this space like that. It will not be able, it needs to be more. So 2.6, we're going to be adding extra 50 on both sides. That will be making it what 2.7. So for that side we'll be having what 2.7, and then we'll close. Now the next part we're going to be having would be what this little space here, which the dimension is what 100 mm. So we're going to book 0.10 and then we close. So the next part we're going to be booking for would be this side here, from here to here. We need to cover it with foam so that the concrete poured on the landing will not start pouring on these steps. So to measure that part, we are going to be using what the width, because if from here to here is 1200, that means here to here is the same as 1200. So we'll book 1.20 and then you close. Doing this, you measure for the what sides of your what landing. So the last thing we're going to be measuring for now would be the soffit of the landing. So now you take your section. This is the soffit of your landing. Now they've not given us the length of this soffit. However, we have 1200 as the top dimension of your landing, but this dimension from here to here is lower than this 1200 that they've given us. So how do we find for the dimension from here to here? We know that from here to here would be the dimension of our thread. So this part is as long as our thread, which is 333. So if we minus 333 from 1200, whatever we get would be our what x, that's this part for our landing. So 1200 minus 333 would become what 867. So we have one parameter 867. I told you that the surface is measured in what meters square. So if you have 800 and what 867, then the next parameter would be the width of the landing, which would be from here to inside here. That's into in, because the formwork will not enter into the wall. It will stop at the edge of the wall, and they've given us that parameter as 2,500. So we'll now book 0.87 by 2.50, and then you close. So this will be 2.70, this will be 0.10, this will be 1.20, and if you do the operation for this, 0.87 times 2.50 will now be equal to 2.18, and then you close. So you've described plain formwork to the side and Soffit of the landing. So the next thing we're going to be booking for would be the formwork that we laid underneath the string. That's the Soffit of the staircase. There have to be formwork under so that concrete will not pour out. So measure for that, we are going to be needing the width of the staircase, which is this 1,200, then by the length of the string, that's the sloping side of the staircase. So we're going to be needing this parameter, which is x, and then we're going to be needing the width of the staircase. So now we know that we've calculated our x. We calculated our x as 3,385.65, approximately was 3.39. So it will now become 3.39 by 1.20. So we can now describe ditto Soffit of staircase string. So if you do this operation, 3.39 times 1.20, it will give me 8.14, and then we multiply it by 2. Why are we multiplying it by 2? I'm multiplying it by 2 because the size of formwork we are going to be laying in the first flight will be the same size of formwork we are going to be laying on the second flight, because the dimensions are the same. So 3.39 times 1.20 times 2 will give me 8.14, and then I close. So when I add everything together, the total quantity would be 42.70. So this will be the total quantity of formwork that we're going to be needing to construct that particular dog leg staircase. So we've come to the end of today's video, guys. I hope you derive adequate knowledge from it. Please, if you have any question, I would love to see it in the comment section. Please don't forget to like, share and subscribe to this channel, because it helps the channel grow. In the next video, we're going to be treating about the reinforcements for this staircase, so stay tuned. Thank you, and we'll see you in the next video.